Hello there guys, and welcome back to another epic inexorable video. In this video we're taking a look at part 2 of solving quadratics using a substitution. We've got in this question x minus 7 root x plus 10 equals 0. So that means x times 7 times the square root of x plus 10 equals 0. Let's just get straight into it. First of all, you're going to look at that and think, unless you're sort of one step ahead of me, you're going to look at that and think, I've actually got no idea how to do that. I've got no bloody clue. Well, I'll tell you how to do it. We're going to do a substitution again, aren't we? Because that's what the topic of the video is. So I'm going to just rewrite this. I'm not even doing the substitution, I'm just rewriting it, okay? X minus 7x to the power of a half. Why a half? The square root of x can be written, as we should know from the index laws video, the square root of x is the same thing as x to the half plus 10 equals 0. Now, I think things might be revealing themselves. Okay, let's think of x as x to the power of 1. They're the same. X to the power of 1 is the same thing as x. We just don't write the 1 because, I mean, why would we? It doesn't really make any sense that we'd write that. Okay, in the previous video I said you can solve a quadratic equation or any equation that's we call them polynomials. Any polynomial in which we have some power of x and then, you know, plus or minus whatever, like the same x but to the power of half the original. Well, that's a 1 and that's a half, and there's a constant there and it's equal to 0. So we can do it. We can do this. So I'm going to say this requires a little bit of outside the box thinking, but I'm going to rewrite x as x to the half squared. This just, I mean, okay. First of all, again, brackets power. If it's being squared, we times the powers together. 1/2 times 2 is 1. So yes, x to the half is indeed x to the half to the power of 2 is indeed x to the 1, which is x. That's fine. But look at it. It's just obvious because this means the square root of x. So the square root of x squared, yes, is obviously going to just be x. That's the definition of squaring something and square rooting it again. You just get back to the beginning of where you were. You take the square root of a number, then you square it, you're back to where you were. You take the square root of 25, which is 5, and then you square 5, yes, you're back at 25, logically. So this makes sense. And then we're going to take away 7 times x to the half. Again, that's literally just what was written. I'm just putting brackets around it. Plus 10 equals 0. Perfect. Okay. Right. Now I'm going to come more over here because otherwise we're going to run out of space. I'm going to say, and today, guys, let's do a t instead of a u. I'm going to say let t equal x to the power of a half, or square root of x. Why am I doing that? Because now we can say that, well, that's, if x to the half is t, then there's a t there, and it's being squared, isn't it? There's the square, there's the t, there's square. Minus 7 times x to the half. X to the half is, again, t. So minus 7t. Okay, and then plus 10. Okay, guys. Once again, this is a quadratic that we know how to solve. We can either use the quadratic formula, or we can complete the square, or we can use our plain old method. For the sake of time, this doesn't look like a particularly difficult problem. Let's just do our normal method. Let's find two numbers that multiply to make 10 and add to make minus 7. Pause the video if you want to think about it. I'm going to tell you the answer. Those two numbers are going to be minus 5 and they're going to be minus 2. Because minus 5 times minus 2 is positive 10 and minus 5 plus minus 2 is indeed minus 7. That's equal to 0. Boom. Now, using our normal stuff that we already know how to do, that implies How do we make each of these brackets be equal to 0? If we make t 5, then 5 minus 5, that's 0. So one of them is when t is 5. So t is equal to 5. And if we make t 2, then that's a really good film. If we make t 2, then indeed that bracket's also equal to 0. So t is equal to 2. Boom. Okay, valid. T is 5, t is 2, we've just figured it out. We don't want t, guys. We don't care about t. Who cares? We just made it up. We made it up. We just randomly made t in this question. But what we do know is that t is equal to the square root of x, or x to the half. So if t is equal to 5 and t is equal to 2, then that means that x to the half, which is, let's just write it now as the square root of x, is equal to 5, and also the square root of x is equal to 2, isn't it? So let's just solve this problem. If the square root of x is equal to 5, well, let's just square both sides. Square root of x is equal to 5, then x is equal to 25, okay? If the square root of x is equal to 2, then x is equal to 4, okay? Because if you take the square root of both of these, you will get the square of x is equal to the square root of 4, which is 2. So the answers to this problem, we'll do them over here. X equals 25 and x equals 4. Boom. Now that's technically not a quadratic, is it? Because this is not written in the form ax squared plus bx plus c equals 0, clearly not. But do you see how we can still use quadratic equations and the quadratic formula and all of the skills that we've learned? Technically, yes, you could do this by completing the square as well, to solve questions that just don't look anything like a quadratic. I think that's really cool, really nifty. So yes, our answers are x equals 25 and x equals 4. If you guys want me to make more of these videos by using a substitution, please let me know. Other than that, we're going to move on to some crazy things. We're going to start talking about functions, and then we're going to look at sketching quadratics, the discriminant, and then we're basically done with quadratics, which is that's exciting, right? We can move on to some new stuff. If you enjoyed this video, please give it a like, please subscribe, tell your friends all about it, and I'll see you guys in the next one.